All right, we're still in chapter 18, and this is part 2, and this is actually going to be a really, really short part. We're going to start off by talking about the pathway of blood through the heart. And I'm just going to read this to you, but then we're going to look at a diagram, not on the next slide, but the slide after that, which is going to go through the pathway of blood through the heart. So we're going to start off, and it's either going to so we're going to have blood returning to the right atrium. Generally, this is often how books start. The pathway of blood to the heart is the blood returning to the right atrium. So it's going to return to the right atrium via the superior vena cava, inferior vena cava, and coronary sinus, and then go into the right atrium. From the right atrium, it's going to pass over the tricuspid valve and go into the right ventricle. From the right ventricle, it's going to go through the pulmonary semilunar valve and go into the pulmonary trunk, which is then going to go into the pulmonary arteries and then into the lungs. From the lungs, it's going to do its thing, drop off CO2, pick up O2, and then we have 4 pulmonary veins that are going to deliver the blood back to the left atrium. Then the blood will flow over the mitral valve into the left ventricle, through the aortic semilunar valve, into the aorta, and then through systemic circulation. And then that's when we would start back over again. So, going over this as a diagram. Superior vena cava, inferior vena cava, and then coronary sinus, which would be in here, all pumping blood back to the right atrium. From the right atrium, it passes over the tricuspid valve into the right ventricle. From the right ventricle, right ventricle, it goes, through the pulmonary semilunar valve into the pulmonary trunk. And then from there it'll go, and then it'll go into the pulmonary arteries, then to the lungs. And then again, blue, it usually denotes deoxygenated blood. So you're pumping deoxygenated blood to the lungs, where it's going to drop off CO2 and pick up O2, and now red denotes oxygenated. So here we have oxygenated blood, and it's going to go back to the heart. So we're going to pick up here, and we're going to deliver the blood back to the heart via the pulmonary veins. 1, 2, 3, 4. Those are going to then pump the blood into the left atrium. It is going to go over the mitral valve and into the left ventricle. Then from the left ventricle, it's going to go through the aortic semilunar valve and into the aorta, and then to the body, where it's going to drop off oxygen, pick up CO2, and do a number of other things. And then it'll go back to the heart. And that's just the whole thing together if you wanted to see it as one whole diagram. So equal volumes of blood are pumped to the pulmonary and systemic circuits. However, the pulmonary circuit is short and it's a low pressure circulation. The systemic circuit is long and it's high friction circulation. The anatomy of the ventricles actually reflects the differences here. And what this means is that the left ventricle, which is going to pump through the systemic circuit, is 3 times thicker than the right ventricle that pumps through the pulmonary circuit. And we can see this difference reflected here. So this is about 3 times thicker than the wall of the right ventricle. So this would be the left ventricle, this would be the right ventricle. If we were to actually have lab, you could feel this in the heart. You can see it, but you can actually really, really feel it. And then we talk about coronary circulation. And so what coronary circulation does is it supplies blood to the heart muscle itself. It's the shortest circulation in the body, and it's delivered when the heart is relaxed. The left ventricle receives most of the coronary blood supply, which makes sense because the left ventricle is what's working the hardest. Both left and right coronary arteries arise from the base of the aorta and supply arterial blood to the heart. They both encircle the heart. And then the branching of coronary arteries is going to be different from person to person. But the arteries themselves are going to contain many anastomoses, which are just junctions. And what these do is they just provide additional routes for blood delivery, but they cannot compensate for coronary artery occlusion. So if the coronary artery is occluded, even these anastomoses are not going to allow the blood to bypass the occlusion and still deliver enough blood to the heart. The heart receives 1/20th of the body's blood supply. So what I do want to point out is that the blood that's inside of the ventricles is not actually oxygenating the ventricles. It is coronary circulation that's doing that. So you can see, again, this would be just a general kind of depiction. You have the left coronary artery, and then branching down, we have the right coronary artery. And then this is just a same thing, but we're looking at the back now. Great cardiac vein, and you're not going to be asked to identify this stuff in lecture, but coronary sinus, and then just more coronary circulation. And then your question. Oh, it says questions. It is just a question. I usually catch that, but I didn't catch that this time. Technically, it is multiple questions, so it is questions. All right, that's all I've got for you.